Okay, till now we have seen the problems where the charges were kept on a straight line like this. Okay, let's say this is Q1, Q2, Q3 and so on, right? So till now we were seeing the problems like this, but we never saw a problem like this where the charges are not in one straight line. Okay, now we are going to look at that type of problems, right? Okay, now there are four charges plus q, identical charges, placed at the vertex of this square, and at the center there is a positive charge plus q0. I want to find out the net force acting on the q0, right? Okay, so let's do that. This is at the center, okay, at the center. So and the side length of the square is a. So first thing, due to this plus q charge, there will be a force on plus q0, right? There will be a force on plus q0. And what is this distance, right? See, if I extend it, this will become a diagonal. This is a, this is a, this has to be root 2a. This whole diagonal of a square, diagonal of a square is equal to root 2a, because it is square root of a square plus a square, right? This is a right angle triangle. Okay, now this distance is halfway between, right? So this distance is root 2a by 2, root 2a by 2, which will be a by root 2, a by root 2. So this distance, this is center, let's say O. This distance will be a by root 2. This distance is a by root 2, correct? Now the force between this q0 charge and plus q will be repulsive force, that is in this direction, right? This will be in this direction, and if you want to find out that force, it will be kq0 by a by root 2 square, because the distance between the two charges is a by root 2. So this will be a by root 2 whole square, which will be kq0 divided by a square into 2, right? So that force, let me call this whole thing as F, okay, the force. So here that force will be applied, F, but that is in this direction. Now let's look at this charge, okay, this charge we have done. Let's look at this charge. If you see, the distance between plus capital Q and Q0 is same as this distance, which is a by root 2, right? So that means the force will be same again. The force magnitude will be same, because it will be K capital Q Q0 divided by a by root 2 square only. The force magnitude is same, but it is in opposite direction. So it will be in this direction. Okay, it will be in this direction, again the same magnitude, but the vector is different because it is in different direction. Now these two forces are equal and opposite, so they will cancel out, right? The same logic if you apply over here, this distance is again a by root 2, this distance is again a by root 2. By symmetry you can see this will be the force F, this force will also be F, and this, both of them will cancel out, and the net force will be 0. Okay, so F net on Q0 is equal to 0, right? That is how you do this question. Okay, let's look at the next question. Again we have a square now, right? And all of the vertices are all of the charges are located at the vertices of the square, right? And you have to find out the force on one of the charges. So let's say we have to find the force on this charge, right? Now this is not at the center, that means net force will not be 0, right? Okay, let's look at that. First let's do this force. This plus q will repel this plus q along the line joining these two charges, right? Note that the electrostatic force is the force which is central force, that means it acts in the direction of the line that connects the center of the two charges, right? Okay, so here because of this, let's call this as first charge. Because of this, the force on this is like this, okay? I will just write F1 bar, okay? I'm not identifying that. So let me call this as one charge, first charge, this is second charge, and this is third charge. Due to first charge, the force is in this direction, right? Okay. Now, see, what is the magnitude of this force, by the way? I will write the magnitude of the force. just for the sake. The distance is a, this is a square, so kq square by a square, right? Okay, this is the magnitude. Okay, now let's look at the third charge, right? The third charge will apply a force which is in this direction. This is F3 bar, right? This is F3 bar. The distance between these two charges again is a, so we can say F3 bar magnitude is kq square by a square, right? This is the again same magnitude, but it is in this direction. Okay, in case if this charge was not there, then these were the only forces acting. Okay, for a simplicity, let's find out that if this charge was not there, okay, let's assume this charge was not there, then what would be the net force, right? Let's look at that case. So now these two forces are at an angle of 90 degree and both of them are equal in magnitude. Let's say kq square by a square, kq square by a square. Let's call this as small f. Okay, correct? Both of them are same magnitude and at a 90 degree. So if you know, if the angle between the two vectors, let's say this is a bar vector, this is b bar vector, and this is angle theta, then the resultant is given by this formula, a square plus b square plus 2ab cos theta, right? This is the parallelogram law we have done. You have done actually in 11th standard, right? So this is the resultant between of the two forces or two vectors inclined at an angle theta, right? Okay, so now this, when theta is equal to 90 degree, this will become 0. So this will eventually end up a square plus b square with a square root, right? So here also same thing. This is f, this is f. The resultant will be in this direction, which will be root 2f. It will be root 2f. Okay. Now this angle will be 45 degree. This angle will be 40 because both of them are equal, right? So this will bisect. Both of these forces are equal. So this resultant will bisect that angle. So this will be 45 degree. Otherwise you can find out. You can use tan theta and you can take f3 divided by root 2 f. This is f. So f opposite side upon hypotenuse is cos, right? So cos, cos. It is sine. Sine theta is f upon root 2f, which is 1 by root 2. From that you can get 45 degree. That also you can do. Okay, no problem. So the net force is root 2f. So here the net force magnitude will be root 2f. So this will be root 2 kq square by a square, right? If this charge was not there. Now if this charge is also present, then what will happen? This plus q is also present. If this plus q is also present, then this guy along this diagonal will repel this. But now see, you can see that this is along the diagonal and this resultant is also along the diagonal. This is 45 degree, right? So we know this angle is also 45 degree, right? So that means this is a straight line over here and this will apply a force, this plus q will apply a force, let's say f dash, okay? Let's say f dash. I don't know if it is bigger than root 2f or not bigger than root 2f. If it is bigger, then f dash arrow will be longer. If it is smaller, it will be shorter. Okay, so let's find out what is f dash. F dash is equal to magnitude wise kq into q, that is kq square, divided by, this is root 2a. So this is root 2a whole square because this is the length of the diagonal. So this is kq square by 2a square. From here you can see it is half of f by 2. Sorry, half of f. So this will be f by 2, right? So it is not exactly like this. It will be somewhere here, f by 2. So now root 2f and f by 2 are in same direction. Let's erase this. Okay. Root 2f and f by 2 are same in direction. So your net force, I will write net dash, okay, because net we have used here already. It will be root 2f plus small f, right? So root 2f is this force and sorry, not small f by 2, because that is the half of that value. That will be the net force. So this is root 2 plus 1 by 2 kq square by a square. This is your net force, right? This is how, okay, this not. Okay, so that is how you do this type of question. Okay, let's look at another question now. Okay, let's look at this question. We have a small q charge over here. We have to find out the force on the small q charge due to minus q and q. And this is an equilateral triangle. You can see all the sides are equal, right? Okay, let's do that. Now, the force by plus q on this plus small q is in this direction, right? Okay, let's call this as F1. Let's call this charge as first charge, this as second charge, right? Okay, good. Now this second charge will apply a force on plus q, which is attractive because this is negative. So this another force is in this direction. The another force is in this direction, F2. Correct? Now since this is an equilateral triangle, all the angles are 60 degree. All the angles of a triangle are 60 degree. Now this angle will become 120 degree. This angle will become 120 degree. Now what is F1? We will write the magnitude of F1. Okay, what is the magnitude of F1? This is capital Q, this is small q. So this is K capital Q small q divided by a square. And this is F2. Right, F2 is attractive, but I will write the magnitude only. So it is K Q small q divided by a square. Oh, again same, right? Okay, both of them are having same magnitude. Correct. What will be the resultant of these two vectors? The resultant of two vectors we have to find out. Let's say, again I will make this as f, and again I will make this as f. Now these two vectors are inclined at 120 degree. So if I find out the net force, let's write that as f net square root of f1 square plus f2 square plus 2 f1 f2 cos of 120 degree. So this is square root of, what is f1 square? This is capital F, right? Sorry for that. So these all are capital F's. Okay, that will be f square. This will be f square. Both of them are equal in magnitude. Plus 2f square into cos of, see 120 degree I don't know, so I will write it as 90 plus 30. Right? Okay. So this will be square root of 2f square plus 2f square cos of 120 degree. See, what is cos of 120 degree? Cos of 90 plus 30, right? So if I look here, you know this is add sugar to coffee, right? Now cos of 90 plus 30, this is 0, this is 90, 90 plus 30. This is in this direction, in this quadrant. Cos 90 plus 30 is in this quadrant. So this quadrant cos is negative. So it will be minus of sine 30. So it will be minus of sine 30. If you will write, this will be 2f square plus 2f square. Minus of sine 30 is minus half. So this 2 gets cancelled. This is square root of 2f square minus f square. So this will be f only. So the net force is having a magnitude of f only. But now where it will be? It will be somewhere here. Okay, it will be somewhere here. Now note that, how will you find that angle this resultant force make with this vector, this theta? Okay, how will you find that? Okay, so one thing what you can do, see this will be like a parallelogram. Okay, but more actually better than that, it is a rhombus. Why? Because these two sides are equal, right? It is a rhombus. Okay, so now we know another formula as well for the parallelogram law, that is if this is a bar vector and this is b bar vector and the angle between them is theta, then the resultant makes an angle of some alpha, then that tan alpha is equal to b sin theta upon a plus b cos theta. This is according to parallelogram law of vector addition. So now this angle, we will call it as tan theta, is equal to b sin theta, that is f sine of 120 divided by this f, that is a is f, b is also f. but this is cos of 120 degree, right? Sine of 90 plus 30, what is sine of 90 plus 30? It will be cos, but that is positive, right? So this is cos 30, which is root 3 by 2. Root 3 by 2 into f divided by f minus f by 2, because this is cos of 90 plus 30 is minus sine 30, so this is minus f by 2. So this will be root 3 by 2 f divided by f by 2. So 2 gets cancelled, f gets cancelled, and this is root 3. So tan theta is root 3. So from that you can say theta is 60 degree, right? So theta is 60 degree. Obviously it should have been the case because both of these vectors are equal in magnitude. So that means the resultant will be the halfway, right? And one thing I should tell you is that if two forces are at a 120 degree angle with each other, then always if their magnitudes are also equal and they are at 120 degree, then the resultant force will have the same magnitude as one of these forces. Okay, if both of these forces are having same magnitude and they are making angle 120 degree with each other, then the net force is having the same magnitude as either of them, right? Okay, so that you should understand. And this is the angle which will be 60 degree, it will bisect, right? Okay, so these are the questions. Okay, these are the questions that we saw today, right? In the next session we are going to do all the JEE mains questions based on this Coulomb's law of attraction and repulsion, right? Thank you.